In this video, we're going to talk about the concept of recursion. At the end of this lecture series, you should understand the concept of recursion, be able to translate a recursive solution to a problem into a recursive method implementation. So it's saying take a problem description that's naturally recursive and be able to write a method for it. And finally, you'll be able to trace recursive method calls if you are given a program that includes a recursive method. So you're probably wondering, what is a recursive method? A recursive method is just a method that calls itself. And that's something that we haven't seen often in the code that we're writing. Typically, we're writing a main program, and the main program calls your method, and then your method returns back to the main program and continues on in the main. But the method doesn't call itself from inside the method body. On the surface level, a lot of people, when they first hear it's a method that calls itself, they think, well, that just sounds crazy. Why would you ever want to do that? And it's not something that you use every day in computer programming. If you were a software developer, this is something that would occasionally come up, but wouldn't be like an everyday part of your normal workflow. Recursive methods are primarily useful when a problem statement naturally lends itself to a recursive solution. And so those are when a problem happens to be defined in terms of a simpler version of itself. So we'll be looking at a few examples where that's true. Also realize that in this packet of notes, sometimes it talks about recursive functions and sometimes it talks about recursive methods. For the purpose of this particular lecture series, those mean the same thing. So a method is just a group of statements that is bundled together with a name associated with them. Methods are usually part of object-oriented programming, where functions are the same thing, but when you're not doing object-oriented programming. And you can write recursive methods that are used in object-oriented design or not. The solutions that we're looking at in this particular lecture series aren't particularly object-oriented, but they could be part of an object-oriented solution to something. So before we start trying to think through recursive solutions and algorithms, let's just get a feel for how it works. In your notes, there's a small segment of code. And let's just look through that really quickly. So we have a main method here, and it makes one method call to the message method, and it passes in an argument value of 3. And that all looks cool. It looks like it's going to call that method one single time. But then when you look at the method implementation for the message method, you see it takes its parameter times. It's going to print out some information. And then if times is bigger than 0, it's going to call the message method again using a different argument value. So it's calling the message method from inside itself. That means this is a recursive call. And then it's going to print some more information. Now, just looking at this, you probably have no intuition about what will print out to the screen. And so you might want to think for a few minutes about what you think might print out or what might happen. If you want to do that, then go ahead and pause the video. And when you come back, we're going to run it to kind of see if your intuition was correct. So over here in IntelliJ, I have the exact same code loaded up in my IntelliJ window. And if I run it, you can see the output down here at the bottom. And I think that interesting thing is that even though that message method looked like it was just going to be called one time from the main program, we can see that it's actually 3 different pairs of output that gets, or 4 different pairs of output that get displayed as a result of executing this code. So it prints the calling line 4 different times, and then it also prints the returning line 4 different times. So that's interesting. What happens when you do a recursive solution is that it creates a loop. So it's an alternate way of writing a for loop or a while loop, some kind of loop that continues until some particular value or state is achieved in your program. The other thing that's kind of interesting about the output here is that you'll see it prints all of the calling messages before it prints the first returning message. So in other words, when you start a recursive method, it begins executing. That's why it prints the calling message. And then in this case, it makes the Boolean evaluation, checking to see if times is bigger than 0. If it is, it calls the message method again and starts executing this particular method starting at the beginning, but with the new argument value. And it's only after we don't make a recursive call that it starts returning the messages, finishing or completing each of the individual recursive methods. So it goes through all the way until it reaches that kind of base state value where it knows it doesn't need to make any more recursive calls. At that point, it can return the value or complete that method method execution, and then it'll return to the previous call where it had previously been stopped, so that it could make the recursive call and pick up where it left off with that one, and so on with the next recursive method call until it's completed all of the calls that have been started. That's a little bit confusing to trace through for this particular example. I think it'll be easier if we trace through it with some of the next examples that we look at in the notes. So for now, don't spend too much time wrapping your head around the specifics of how this particular method works or what its purpose is. It doesn't really do much useful. I wanted mainly just to show you that using recursion creates a loop in your code. It causes you to repeat an algorithm until a particular state or value is achieved in your code.